Hello everyone, this video let's continue to learn Lesson 10 Part 2, Measures of a Central Tendency. One value will be used to characterize or summarize an entire data set. In the case of numerical data, it's thought to be represent the center or middle of the value. Some data sets are very large with a wide range of the value. So trying to characterize all of the value with one value is a pretty bold undertaking. So let's see what value can represent the center of the data set or represent the whole data set. Our textbook discusses 4 such measures of center. First one is mean, second one is median, then mode, mid-range. First one is mean. Mean of the list of numerical data is defined to be this. So on the top of this fraction, that's the sum of all of the data and divided by how many data do we have. Totally we have n values in this data set. So divided by n. The formula is sometimes written as an abbreviated form as sigma x over n. This notation we call the sigma. It's a Greek letter, means add up all of the data. If the data set represents a sample, so if this is sample, then the mean can be abbreviated as x bar. It is a sample mean. If the data set represents the entire population, then we call this mean, or the mean value is mu. It is the population mean. And most examples in this class, we are talking about x bar, the sample mean. Okay, samples of mean calculation. I have a data set, and finding the mean, the x bar of the sample space, we're going to add all of these data together, divided by how many values are there in the data set, 4. So add the tops, 1 plus 2 plus 2 plus 3 divided by 4. 8 divided by 4 is 2. Okay, mean is 2. Where is my bar? X bar. Okay, second one. 1, 2, 2, 3, 4. Finding the sample mean, we're adding all of data together and divided by how many values do we have? We have 5. 12 divided by 5 is 2.4. Sometimes you see this value 2.4 is not a value from the data set. If you give a rounded value for the mean, always round to one more decimal place than the data value. For example, this question, my mean is 2.4. If I have one more decimals, but I still just keep 1 decimals because in the sample space, these data, they are integers, and my mean at least I need to have 1 more decimals. Okay. Let's see. This stem and the leaf plot. So stem and leaf plot is also coming from the data set. So the stem is 0. Leaf is 2, that means 2. Stem is 0, leaf is 3, is 3. So 1 is the stem. So leaves are 0, 3, 9. So I'm going to have 10, 13, 19, and for the 20, 21, another 21. Okay, looking for the mean. Let's add them together. 2 plus 3 plus 10 plus 13 plus 19 plus 21 plus 21, all divided by how many values are there in this data set. We just count the leaves. 1, 2, 3, 4, 5, 6, 7. So we have 7 leaves. Do the division. We are going to have, what do we have? I don't have my cheat sheet here. So we can use our calculator and do the addition on the top. So we are having equals 89 over 7. Use a calculator. I think I did the calculation. Yes. 89 divided by 7 is 12.7. 1, 4, something. If I keep only one decimal place, we're having 12.7. Okay, let's see next example. Find the mean, or we're looking for x bar. X bar equals sum up all of the values. And when the value is 1, the 1 happens 11 times. Okay, I'm adding 11 ones. And 2 happens 13 times. We're adding 13 twos. And for 3, we have 22 threes. Totally, we're having 22 threes. Add them together, but we can use multiplication. 11 ones means 1 times 11. 13 twos means 2 times 13. 22 threes means 3 times 22. Add them together, we're having 103. Then divided by how many values in this data set? Total values, numbers is 46. So divided by 46 and use a calculator. We got 2.2. Let's see next example. The frequency diagram. Okay. Let's add all of the values together. So the value is 1. And 1 happens 4 times because frequency is 4. So 1 times 4. The value is 2. Frequency is 3, happens 3 times. 2 times 3. And then 3 times 1, 4 times 1, 5 times 1. So use that value, multiply by the frequency, and add them together. We're having 22 over 10. Division is 2.2. Determine the median of the list of numerical data. You first arrange the value in the order. Now we are learning second definition is median, is not the mean. So median, usually that's the center of the data set. For example, if I have a data set, I'm having some data inside. 1, 2, 3, 4, 5. So this is the ascending order. Yes, I rearrange the values in orders. This is descending order. What is the center of the data set? Here, 3, because 3 is the middle of this data set. Before 3, we have 2 values. After 3, we have another 2 values. That's the center or the middle of the data set. So this is mean. So the mean of this data set is 3. Sometimes we are not having 5 data. We're having more values. For example, 1, 2, 3, 4, 5, 6. We have 6 values. What is the center of this data set? You see, the center of the data set is 3 and 4. We have 2. So before 3 and 4, we have 2 values. After, we have 2 values. But we are only having 1 value to represent the median. We need to find the average of 3 and 4. 3 plus 4 divided by 2, we have 3.5. So the median is 3.5. If there is an odd numbers of values in the data set, median is the middle value. So like here, like this example, we have 5 values. That means we have odd numbers of values. Then the median is the middle value. If there is an even number, so for example, we have 6 numbers in the set. The median is the average of the middle 2 values. For example, we have 5, 2, 6, 3, 8. This is not ascending order. Let's rearrange them. We are having 2, 3, 5, 6, 8. When the number of value is odd, do we have odd numbers? Yes, we have 5 numbers. In the middle is obviously to tell that our median is 5. So we will say our median is 5. Why I'm highlighting 5? I say 3. It is 5. That's the middle number. Okay, let's see next example. We have 6 numbers. Let's rearrange first. 2, 3, 5, 6, 8, 10. And if I cut it into half, you see, first part 3 numbers, last part 3 numbers. We don't have a middle number to balance this data set, but we are going to find the average between the two middle number 5 and 6, and then divide by 2. We have 11 over 2, 5.5. This is the median of this data set. Okay. The median may not be the actual values in the data set. Yes, you see, 5.5 is not inside of the data. Okay, there is another method for finding the median that works well for larger data set. So the simple one, for example, this one, you can tell immediately which twos are our middle numbers, or this is a data set has all the elements. Then we are finding the middle number. It's very easy. But if I have a big data set, what should I do? We are using a formula if we have n values totally. If n is odd number, median is using this odd number plus 1 divided by 2. This is a position, not the actual value, n plus 1 over 2. It's a position. And find that position number, that's our median. If n is even, the median is the average of the value n plus 2. N divided by 2, n divided by 2 plus 1. These two, they are the middle numbers. Two middle numbers. Add them together and then divide it by 2. That's add these two numbers and then divide by 2. That's median. Okay, so finding these two numbers is a very important step. For example, if I have more values in the set, but not too many. So we have 5. If I reorder them, we are having 2, 3, 5, 6, 8. Without using the formula, this set, we are having 5 values. That's odd numbers. In the middle one, this is my median. We call 5 is our median. And if I'm using the formula, totally we have 5 values. And using 5 plus 1 divided by 2, that's 6 over 2, we have 3. But here, the 3 is not our value or median. We are looking for the third position. This is 3RD, third. So which is the third position? 5. Okay, let's see next example. I did the preparation. I list my values in the ascending order. They are 2, 3, 5, 6, 7, 8, 9, 8, 10. Totally, we are having 6 values. N equals 6. Let's highlight 6. And then 6 divided by 2 is 3. So 3 means third position, means 5. And 4 means fourth position. We can let ourselves know the 3 means third. 4 here means fourth position. It doesn't mean the value 3 and value 4. Okay, let's find the third position is 5. Fourth position is 6. So 5 and 6, they are the middle number, two middle numbers. So finding the median, it is adding these two middle numbers together divided by 2. It is 5.5. For this question, median is 5.5. Okay, let's see next example. In this example, we are having a stem and the leaves plot. In this example, how many values in this data set? So I'm going to count the leaves. 1, 2, 3, 4, 5, 6, 24, 25. So we are having 25 numbers. Okay, this is odd number. Odd number means find the middle one. What is the middle number? We have learned the formula. The formula is n plus 1 over 2. And this is the position of my middle number, or we say that's the position of our median. So 25 plus 1 over 2 is 26 over 2 is 13. The 13 here, oh, they already have it. The 13 here is a position. 13 here means 13th position. And let's find where is 13th position. So we have counted the first 6 numbers. Let's keep counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's use different colors. 13, which is 51. My 13th number is 51. That means my median is 51. Okay, let's see next example. Similar questions. How many number of values in this data set? We're having 24. Previous we have one more, 25. This is 24. Okay, 24 data. So we need to break down my data set equally into half. So first 12 numbers, last 12 numbers. And I need to find what is the last value in the first part. What is the first value in the first part? We got a formula. We're using n over 2. This is n over 2. This is the position number. And then n minus 2 plus 1 is also the position number. Okay, n over 2 is 12. Then the value next to 12 is 13. So 12th and the 13th position. Let's find where is 12 and 13th position. 1, 2, 3, 4, 5, 6, 7. So did you see that I didn't rearrange all of these because for the stem and the leaves plot, so they are ordered numbers because small number goes first on the first row, and then big number, big stem and big leaves, they have the big value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's use different color to color 12 and 13. So we are adding these two numbers together, 49 plus 51 divided by 2. 100 divided by 2 is 50. So our median of this question is 50. Okay, let's see next example. What is the median of this question? Looking for the median of the question. I need to find the position number. All right, let's see this. We have 47 values in this data set. What's the meaning of this? This is the odd number. If I have an odd number, we have one middle value. Then I just find this middle value. That's it. So we are using the formula n plus 1 over 2. So 47 plus 1 divided by 2 is 24. 24 means the 24th position. Okay, let's see. So we have 12 ones. So after 12 ones, we are having 2. After 2, we have 3. So we have 12 ones and 13 2. So we have 12 ones. Total we have 12. And we have 2, 2, 2, 2, 2, 2, 2. So many 2s. So all of them together we have 13th. What is my 24th position? So 12 plus 13 is 25. That means the 24th position is still 2. That's the 24th position. And this question, my median is 2 because my 24th position is 2. Okay, let's see next example. Totally, we are having 26 numbers. So we are having 12 ones. Total we have 12 ones. And we have 2, 2, 2. We have 11 twos. And we also have 3, a lot of 3. We have 23 threes. And what is the middle numbers? Or if this one doesn't have one middle number, what are the 2 middle numbers? We have the formula. We're using n over 2. 46 divided by 2. That's 23. So 23 means 23rd position. So this means position. And how about 23 plus 1 is 24. This is also a position. Okay, I'm using the position in 23 and 24. Find the sum and then find the average. Okay, so which is my 23rd position? You see here, we have 12 ones, 11 ones, 11 twos. That means the last 2 is the position 23rd. And the next one is 24. All right, the median equals the sum, the average of these 2 middle numbers. 2 plus 3 divided by 2 equals 2.5. Okay, my median is 2.5. Okay, let's see mode. A list of numerical or descriptive data is defined to be the most frequently occurring value. Oh, this value occurred most often in the dataset. Unlike the textbook, I don't allow for 2 modes or 3 modes. For me, either there is one most frequently occurring value or there isn't. If I see 2 values, it happens equally times, and even they happen to 10 times, but we don't have mode because mode is the only one value that appears most often in the data set. Okay, let's see the mode of this data set. So which value happened most often? 2. So these 2. So value 2 is the mode. And next example, which value happened most often? You see 1, 1, 2, 2. But I cannot have 2 mode. This means this question we have no mode. We can only have one value that happened most often. We cannot have 2 mode. In this data set, we have red, blue, green, green. Obviously, green happened twice more often. So green is my mode. Means and medians only work for numerical data, but this isn't the case of modes. Let's see this one. Which value happened most often? Okay, can I say 39? Because we have 2 39s. No, I have some value happens more often than this. So if the stem is 6, you see we have 3 67s. So mode is 67. Because 67 most often happen 3 times in this data set. Let's see, next example. If I have a value frequency table, and which number or which value happens most often, that is 3. So my mode is the value 3. Next example. which value happened most often? You see, 40. That means frequency of the large. This value happened most often. So my mode is large. Okay, let's see next example. Next definition is the mid-range of the list of numerical data is defined to be average of the smallest and largest data value. So mid-range is smallest value plus largest value divided by 2. Examples of mid-range calculations. If I have 1, 2, 2, 3. Okay, what is the smallest value? 1. What is the greatest value in the data set? 3. Add them together, find the average. We're having 2. So 2 is my mid-range. Sometimes the value of the mid-range will be an actual value in the data set. Yes, this 2 is also a value in the data set, but not always. Let's see this example. Let's find the mid-range. The formula is the smallest one plus the greatest one divided by 2. That's 2.5. So this value is not in the data set, so we don't have 2.5 here. If you gave a rounded value for the mid-range, always round to the one more decimal place than the data set value. Let's see, find the data sets mid-range. Mid-range means the greatest value, smallest value and the largest value. Which one is the smallest value? 2. What is the largest value? 22. So the mid-range equals 0 plus 22 over 2. It is 12. So 12 is the mid-range of this data set. Okay, let's see next example. We have a frequency table, and then we need to find the mid-range. What is the smallest value? We can list them. In the set notation, we have 1, 1, 1, so many ones. We have 11 ones. And we have 2, 2, 2, so many 2s. We have 13 2s. And we have 3, 3, 3. We have 22 3s. Let me ask you, what is the smallest value? I don't have to list them, wasting time. The first number, first element, last element, or we say first value, last value. So 1 plus 3 divided by 2. It is the mid-range. It is 2. Okay, for the data set, a new question. The mode is 2 and the median is 18. Which measure better represent this data? Okay, mode is 2 because 2 happen most often 2 times. But which definition or mode or median can represent the data set? So I'm going to choose 18. Why I'm choosing 18, the median? Because it's the middle of the data set. Even 2 happen twice. But you see the front and so in front of 18, after 18, we have we have the scattered data here. And 2 is the smallest values in this data set. I cannot use 2 to represent the whole data set. So the mean is the better way to describe this data set. Next example, we are having 38, 39, 42, 42, 43, 156. The mean is 60 and the median is 42. Which measure better to represent this data set? Can I say 60? No, I'm going to choose median. So here is the median. And also second question, is median. So median is a better way to represent this data set, because you see, if I choosing mean is 60, 60 is probably the number here, more than 43. But most numbers, they are 38, 39, 42, 42, 43. And only one big number, 156. So the mean is at this position. I didn't keep the balance of this data set. So I'm going to choose the median to represent this data set.